Find the sum of all numbers between 200 and 400 which are divisible by 7. So what is the first number that is divisible by 7 between 400 and 200? It will be 203, right? After this it will be 210, 217 and so on, right? These numbers are, I am writing the next number by adding 7 in the previous. So after 203 this will be 210 which will be divisible by 7. So what will be the last number? If you divide 400 by 7, it will give you 7 5s are 35, 7 7s are 49. So 399 will be completely divisible because this gives me 1 as my remainder, 400, right? So if the previous one, that is 399, will be completely divisible. So these are the numbers of which I want the sum. I have got first term which is 203. I have got the common difference which is 7. This is clearly an AP, right? And what is the number of terms? I need to find out. So what I'll do is I'll put 399 equal to first term plus n minus 1 into the common difference which is 7. So this will be n minus 1 into 7. 399 minus 203 will be 691. So n minus 1 will be equal to 196 by 7, that is 7 2s are 14, 7 8s are 56. So n minus 1 is 28, hence n is equal to 29. So I can say n is equal to 29. So what will be the sum? Sum will be equal to n by 2 twice of the first term plus n minus 1 into the common difference. N minus 1 also can be written directly. 29 minus 1, that is 28. So it will be 28 into 7. Okay. So first of all, let us take care of this 2. So I will cancel this and this will be 14. So what is the calculation left? 29 into 203 plus this is 14 into 7 is 98. So 29 into 98. This is what I need to calculate, and let me keep 29 outside. That would have been a little more simpler. 98 plus 203 is 301. So what I have done here is I have kept 29 outside and added these. So that gave me 301. 301 into 29 can be done like this. 29 into 300 plus 29. So that will be equal to 27, 2, 6 and 8. So 8700 plus 29 here. So the answer will be 8729. This will be the sum of all the numbers between 200 and 400 which are divisible by 7. Okay, let us proceed to the next question. Find the sum of integers from 1 to 100 that are divisible by 2 or 5. 2 or 5. So how do we do that? We will find sum of all integers that are divisible by 2, and we will find sum of all the numbers that are divisible by 5. Now when I find this sum, that is the number divisible by 2, and when I find this sum, that is the number divisible by 5, I have calculated the sum twice for numbers divisible by 10, because those numbers will be divisible by 2 also and those numbers will be divisible by 5 also. So I have calculated these numbers twice. To take care of that overcounting, I will subtract numbers divisible by 10 once. Now this will give me my answer, that the numbers divisible by 2 or 5. Okay. So from 1 to 100, if I find the sum of numbers divisible by 2, it will be 2 plus 4 plus 6 plus and so on till 100, right? So from 1 to 100 there are 50 even numbers and 50 odd numbers. So obviously these are 50 numbers. So what will be this sum? 50 by 2 twice of the first term, which is 2 into 2, that is 4, plus 50 minus 1 into the common difference, which is again 2. So this is equal to, this is 49 into 2, 98, 98 plus 4, 102. So 102 into 50 by 2. Can I write it as 100 by 4? So that it will become 102, 00 divided by 4, which is equal to 2550. Okay. Now I will find the sum. Let us denote it by some Sx. Okay. So let us denote sum of the numbers divisible by 5 by Sy. So it will be 5 plus 10 plus 15 plus and so on till 100. If you notice, this 100 is also repeated. So what I am doing is I am calculating the sum of numbers divisible by 10 twice. That is why I have to subtract it once. So I hope you understand. How many numbers are these? From 1 to 100. So see, at every fifth step I am taking a number. So 100 by 5, that is total 20 numbers are written here. So 20 by 2 into twice of a, that is 2 into 5, plus 20 minus 1 into the common difference, right? So it will be equal to, this is 10 outside and inside this 10, and this is 19 into 5, that is 95. 95 plus 10 is 105. So effectively this is 1050. Okay. How did I find that these numbers are 20? Number of terms in this series is 20, because when you have 1, 2, 3 and up to 100, at every fifth step I am writing a number. Every fifth step. How many fifth steps will be there? 20 such steps will be there. That is how I found this number of terms 20. If you are not comfortable with this idea, what you can do is you can write this 100 equals first term plus n minus 1 into the common difference, which is 5, and then you will see this is 95 equals n minus 1 into 5, and when you divide this by 5 it will give you 19. So n minus 1 is equal to 19, hence n is equal to 20. This is another way you can think about it. Now the only thing left is to calculate Sz. Let us denote this by Sz, numbers divisible by 10. This is Sy, this is Sx. So obviously there are 10 such numbers, 10, 20, 30, 40, right? There are 10 such numbers. So 10 by 2, twice of, and you are free to calculate number of terms by this method also, right? Because for the examiner you may have to show it like this. Why I tell you this way of counting it otherwise? Because I want to open up your minds to various possibilities, because I am teaching mathematics here. I am not teaching any other subject. In mathematics you need a lot of intuition, a lot of aptitude. Okay, so n by 2 plus twice of a, which is 10, plus n minus 1 into d, which is again 10. So this is 20, this is 9 into 10, 90. So this is 110 and this is 5. So 550. Now I need to add these. So this is 2550 plus 50, 2600, 3600. 3600 minus 550 will give you 3050. This should be your answer. Sum of all two-digit numbers which when divided by 4 yields 1 as remainder. So we are looking for numbers of the type 4k plus 1, that when I divide a number by 4 it should give me remainder 1. So 5 is such a number. If I divide it by 4, 1 is also such a number. If I divide it by 4, it will be the remainder itself. When I divide 5 by 4, it will give me remainder 1. What will be the next such number? 9. Okay, let us look at the question now. Sum of all two-digit numbers. We are looking for two-digit numbers, not single-digit numbers. So two-digit numbers start from 10 and go up to 99. Out of these, I need the numbers which when divided by 4 give me 1 as my remainder. So the first such number will be 13, right? When I divide 13, 12 is completely divisible by 4, so 13 will give me a remainder 1. After this 17, after this there will be, I'll keep adding 4, 21 and so on. What will be the last number? 96 we know is completely divisible by 4, right? So 97 will give me remainder 1. So these are the numbers of which I need to calculate the sum. So 13 plus 17 plus 21 plus up to 97. Okay, now first term is 13, common difference is 4. What is the number of terms? I'll put 99 equals first term plus n minus 1 into d. So n minus 1 into d, that is 4, is equal to 99 minus 13, which will give me 6 here and 8 here. So n minus 1 is equal to 86 by 4, right? There is some mistake. Yes, there is, because this was 97. I have written 99 here. So it should be 97. 97 minus 13 will be 84. Because how did I find that there was a mistake? Because this is not coming out to be an integer, right? 84 by 4 is 21. Now it is correct. So n is equal to 22. Number of terms is 22. This was a very simple mistake. Okay. I hope you will not make such a mistake in the examination. Even if you make such a mistake, after this step, when you see that 86 cannot be divided by 4 here, and what I am looking for is an integer, right? So you revisit your calculations, then you have found that 97 should be here and not 99, right? Okay, let us proceed. So S is equal to n by 2, that is 11, or let me write it in detail first, then I'll do the calculation part. Twice of a plus n minus 1 into d, which is 4. So it is equal to, this is 11, this is 26, this is 21 into 4, that is 84. 84 plus 6 is 90, 90 plus 20 is 110, 11 into 110 will give me 1210, because 11 into 11 is 121, then there is this 0. If f is a function satisfying this, then for all x, y belonging to natural numbers, such that f of 1 is directly given, it is equal to 3, and then summation x goes from 1 to n, f of x is given as 120. What does it mean? That I will put values of x going from 1 to n, right, and all natural numbers. So 1, 2, 3, 4, and then keep adding them. So this expression here is nothing but f1. First I put x equal to 1, then I'll put x equal to 2 and add this, right? Then I'll put x equal to 3 and add this, x equal to 4 and add this. Till what time? Till f of n, and it is equal to 120. This is the short form of this. Okay. So f of 1 I am already given, and I need to find value of n. Okay. So I need to find number of terms here. F of 1 is given. What about f of 2? How can I find that? Let me use this relation. F of x plus y, you see, is equal to f of x into f of y. So f of 1 I know is 3. How can I find f of 2? Let me put x and y both equal to 1. So that will be equal to f of 1 into f of 1, right? This is a simple aptitude problem, right? So f of 1 I know is 3. So 3 into 3, it will give me 9. F of 2 I have got equal to 9. How can I think about f of 3? Now let me put x equal to 2 and y equal to 1. So f of 3 will be equal to f of 2 into f of 1. that is equal to f of 2 is 9 and f of 1 was 3. So it is equal to 27. How do you think about f of 4? It will be equal to f3 into f1. So what I'm doing is, whichever term I want, I am multiplying its previous term by 3. Right? That is how I am getting the next term. I multiply this by 3 and obtain this. Multiply this by 3 and obtain this. So this is going like a GP. So this is a GP in fact, because this is 3, this is 9, this is 27, right? And this is 81 and so on, right? I hope you got the idea. So this is a GP with first term as 3, common ratio as 3. So what can you say about f of n? It will be equal to the previous term, that is fn minus 1 into 3. So what is happening here is, if you see this term, this is 3, this is 3 squared, this is 3 cubed, right? So this will be 3 raised to power n, and this sum is equal to 120. Okay, now I need to find value of n. So let me rewrite this question. I hope you have noted everything that you wanted to. So the question that is given is 3 raised to power 1 plus 3 raised to power 2 plus 3 raised to power 3 up to 3 raised to power n is equal to 120, and I need to find value of n. Can you now find it? Because this is a GP where first term is, so let me write the sum of this GP. It is a r raised to power n minus 1 divided by r minus 1. A is 3, r is 3, so 3 minus 1, and it is equal to 120. So this will come out to be 3 raised to power n minus 1 equals, this is 120, right? So this will become 40, and when this 2 gets multiplied here, it will become 80. So 3 raised to power n is equal to 81, hence n will be equal to 4. So this is your answer. The sum of some terms of a GP is 315, whose first term and common ratios are given. So this is GP, first term is 5, common ratio is 2, and sum of some terms is 315. Let us say this is sum of n terms, right? So what is sum of n terms of a GP? A r raised to power n minus 1 divided by r minus 1, and it is equal to 315. So let me put value of a and value of r in this. 5, 2 square, this will be, r is 2, so 2 raised to power n minus 1 divided by 2 minus 1, which is 1, is equal to 315. So 2 raised to power n minus 1 is equal to 5 6 are 30, 5 3s are 15, right? So 2 raised to power n is equal to 64, hence I can say n is equal to 6. So number of terms is equal to 6. And what is the sixth term or the last term? That is a6. It is equal to a plus 5d or a plus 6 minus 1 into d. So this is 5 plus 5 into, okay, we are talking about a GP here, not an AP. What is the sixth term? A r raised to power n minus 1, that is a r raised to power 5. So it is equal to 5 into 2 raised to power 5. So it will give you, this is 32, this is 5. 5 into 32, so 160. This will be the last term. Let us look at the next one. The first term of a GP is 1. So A is 1. Sum of the third, what is third term of a GP? A r squared, right? And fifth, that is AR raised to power 4. It is equal to 90. We need to find R. This is a very simple question. A is 1. So if I replace this A with 1, I'll have R square plus R raised to power 4 equal to 90. So if I take R squared common, I'll have R squared plus 1 equal to 90. Okay. So R square will be an integer and R square plus 1 will also be an integer. So basically 90 is a product of two integers A and B, let us say, where A and B are separated by 1. That is, what I mean is, if 3 and 4 are factors of 12, right? 4 is 1 more than 3. So we need to find two factors of 90, out of which one factor is 1 more than the other. So think about factors of 90 like this: 90 into 1, 45 into 2. Then you need to think 15 into or 30 into 3, right? After that you will think about 15 into 6, right? Then you will think about 10 into 9. Now these are separated by 1. So this here is 10, this here is 9. It is equal to 90. So what can I say about R squared? R squared is equal to 9. Hence R is equal to plus minus 3. And if this is what I need to find, common ratio of a GP. Okay. So this is perfect way to find it using this factorization technique. Otherwise, if let us say your school says that you need to find using quadratic equation, that can also be done, because you can write it as R raised to power 4 plus R square minus 90 equal to 0. Then you need to factorize this middle term, that is R raised to power 4 plus 10R square minus 9R square minus 90 equal to 0. In the similar fashion, you will find R squared equal to 9, or there will be another term that you will find R square equal to minus 10. So we are talking about real numbers here. So we will reject this and select this option only, and we will write that R is equal to plus minus 3. Okay. All right.